Welcome to today's Explainer. We're going to dive right into the mind of a guy whose very name is literally a synonym for genius. You know who I'm talking about, right? Albert Einstein. He's kind of the ultimate architect of modern physics. We're talking about the man who completely flipped our understanding of the universe, of time, light, and gravity totally on its head. I mean, his discoveries didn't just add a chapter to the science textbooks, they basically took a bulldozer to the old foundation and poured a completely new one. And that foundation? It's exactly what makes all of modern physics possible today.
But, before we get completely lost in the heavy science today, we really got to ask ourselves a pretty crazy question. How did a curious kid's simple, everyday questions literally change our entire understanding of the universe? Because as you'll see, world-changing physics didn't kick off in some billion-dollar high-tech lab. Nope, it started super simply, just with childlike curiosity. Just a young boy looking out at the world, noticing nature's little secrets, and absolutely refusing to take, well, that's just the way it is, for an answer.
Okay, let's dive into this. Here's the roadmap for what we're covering today. First, we'll look at the sheer power of his early curiosity. Then, we hit his famous miracle year of 1905, break down relativity and mass energy equivalence, check out the light research that actually snagged him a Nobel Prize, and finally, we'll wrap things up with some of his life lessons.
Section 1. The Power of Curiosity. From Ulm to scientific research. Before we can really grasp the genius, we've got to understand the human being behind all that math.
So, picture this. It's 1879, and Albert Einstein is born in Ulm, Germany. Right from the get-go, even as a little kid, he was just relentlessly curious. He had this deep, almost obsessive need to figure out the hidden gears turning behind nature. He wasn't just casually watching the world go by. He was asking incredibly tough questions about how the universe actually worked. The kind of questions that took most experts years to even start answering. And honestly, that habit, just asking the hard, fundamental questions, that laid the very groundwork for everything else. He carried that exact same energy right into his university years, where he totally immersed himself in math and physics, basically dedicating his entire life to cracking the universe's code.
Moving on to Section 2, the miracle year 1905, a revolution in science, because all that childhood dedication built up to a period that literally changed the scientific world forever.
The year is 1905. In the science community, this is famously known as Einstein's miracle year. And why is that? Well, in just this one single year, Einstein published a batch of research papers that completely, utterly upended our entire grip on reality. And here's the kicker. He wasn't some famous tenured professor at the time. No way. He was a 20-something patent clerk, just a guy working a day job. Yet, the stuff he published in 1905 sparked a scientific revolution that, I kid you not, we are still actively building on today. Section 3. Relativity and mass energy. Breaking down his most famous theories. Let's pivot to the really juicy stuff, the core science of today's explainer. We're going to break his absolute biggest theories down into super simple concepts.
First up is the theory of relativity. This is, without a doubt, the absolute cornerstone of Einstein's legacy. So to break this down really simply, before Einstein came along, scientists pretty much assumed space and time were fixed. Just a rigid, unchanging stage where the universe did its thing. But Einstein? He showed us that space and time are actually woven together into this flexible, stretchy fabric. Think of it kind of like a heavy bowling ball sitting in the middle of a trampoline. That ball creates a deep dip, right? And smaller objects naturally want to roll down into that dip. Well, that dip is exactly what we experience as gravity. It's wild. And it gets even crazier. Depending on how fast you're zooming through space, time actually bends and stretches for you, compared to someone who's just standing still.
Now, what's really interesting here is the sheer deceptive simplicity of what we're looking at. E equals mc squared. It is arguably the most famous equation in all of human history, born directly out of his relativity research. But what does it actually mean for us, in plain English?
Well, Einstein realized something profound. Mass and energy are intrinsically interconnected. Basically, they're just two different forms of the exact same thing. Now, that little c² part, that stands for the speed of light multiplied by itself. That is an astronomically huge number. So, to put that mass-energy equivalence into perspective for you, if you could somehow take the mass of a single, tiny paperclip and convert it entirely into pure energy, it would unleash roughly the same explosive force as an atomic bomb. Yeah, from a paperclip. It's that profound mathematical link between mass and energy that ultimately kickstarted the entire field of nuclear science.
Section 4. Light and the Nobel. How energy and light behave. Because believe it or not, Einstein didn't just rewrite the rules for space, time, and mass.
So flashing back to that miracle year of 1905, Einstein was also publishing groundbreaking research on the actual nature of light. He helped us realize that light isn't just a continuous wave, like water, but it actually behaves like little tiny packets of energy too. And here's a fun fact for you. This idea was so revolutionary that it was actually this work on light, not his famous theory of relativity, that won him the Nobel Prize in Physics back in 1921. He just kept pushing boundaries for decades until he passed away in 1955, leaving behind a legacy that's, well, immortal.
But here's why this really matters to you and me today. His legacy is definitely not just some dusty history lesson. His ideas are literally powering our world right now. Without his theories on time and gravity, the GPS routing you on your smartphone, totally useless. It wouldn't work at all. Our whole approach to exploring space relies completely on his rules. So many massive fields in modern physics are entirely built on the foundation he poured.
Which brings us to Section 5, Einstein's life lessons. Philosophy beyond the laboratory, because the guy was so much more than just complex equations. Einstein was a huge believer that our moral responsibility is just as critical as our scientific knowledge. Actually, scratch that. He thought curiosity and imagination were even more important than pure facts. He was constantly urging people, don't be afraid of the tough questions. He insisted that real education is about deep, fundamental understanding, not just blindly memorizing stuff. And above all else, he felt strongly that science and humanity absolutely have to work together. He was a champion for lifelong learning as the only real way to grow, proving time and again that the absolute biggest ideas in history usually start as the simplest little questions.
I really want to pause on this one core philosophy for a second. Asking questions and staying curious is the most important part of learning. Honestly, if you take away one thing from today, make it that. Einstein's entire life is basically a masterclass in showing us that human knowledge isn't stuck behind some fixed boundary. With enough deep curiosity and relentless digging, we can always push the limits of what we know just a little bit further.
So that brings us to our final thought for today's explainer. Think about it. If a guy working a desk job at a patent office could ask a couple of simple questions and completely rewrite the laws of the universe, what kind of impossible mysteries might you solve if you just decide to stay curious? Keep asking those questions, keep looking a little deeper, and I'll catch you in the next explainer.